Hello students. So after a very short vacation, very short autumn vacation, we are back with our studies. Okay. So before the vacation, we have completed the second chapter, acids, bases and salts. Then I asked you to complete all the textual exercises. I hope you have done it. Then in this session, along with this video, I'll be posting the answer key of those questions also. So you just cross check it whether it is correct or not and submit. All of you must take the photo of the second chapter note and send it to me. It's a must. Everyone should do it. Okay. There won't be any other information that I will give you. So after watching this video, after completing all the textual exercises, after cross checking it, you send your notes to me for me to check it. Okay. So we have covered our second chapter. We are moving to the third chapter, that is metals and non-metals. Okay. In the 9th standard, you may have studied something about the metals and non-metals, right? We know about what is a metal, what is a non-metal, what are the common examples of the metals and the non-metals also, right? We have studied certain properties also. I hope you remember it. Ductility, malleability, sonorous. These are some terms that also we have studied in our lower grades. Okay. So in this chapter, we'll study in depth about the metals and the non-metals. What are the main physical and the chemical properties of the metals and non-metals. Okay. And you know that CBSE has reduced topics of certain chapters. So first and second chapter of chemistry, there is no change at all. But in the third chapter, the last topic, the occurrence of the metals, that topic is removed from the syllabus. So all the other topics are the initial, all the chemical properties, physical properties, then the reactivity series of the metals, then the ionic compounds. These all topics are there. But the last topic, that is occurrence of metals, how we can extract out the metals from its ore. That particular topic is removed from the current syllabus. Okay. So we are not studying about that. Until that, all the other topics are there. Okay. So we can watch today's video. So in this video, we are going to study mainly about the properties of the metals. Physical properties you already studied, but we will just revise it. But there are certain exceptional cases that also we will discuss. Then we will study something about the chemical properties of the metals and non-metals also. Okay, so we can watch today's video.
So let us study about the physical properties of metals and non-metals. Okay, so we are going to study about the physical properties. Okay, physical properties of metals and non-metals. So what are the main physical properties of metals and non-metals? So first we can study about the metals. Okay, so what are the main examples of the metals? Can we just note it down? What are main examples of metals? Do you remember it? Yes, iron. Iron is an example of metal. Then copper. Copper. Then aluminium. Aluminium, how will we represent it? Al, right? Then magnesium, Mg, right? Sodium, Na, right? Lead, Pb, then zinc, Zn, etc. So these are the main common examples of the metals: iron, copper, aluminium, magnesium, sodium, lead, zinc. There are several. When you take the elements, we have found out 118 elements. In that, most of the majority of the elements are metals itself. So these are the examples of the metals. Now we can study the physical properties of the metals one by one. Okay, so the first property of the metal is that they have a very shiny surface, right? They have a very shiny appearance. So we call that property as the metallic leisure. Metallic luster. So what is metallic luster? It is a shiny appearance of the metals. So metals exhibit luster property. Normally majority of the metals are hard, right? They are normally hard. So metals are normally hard, right? Then there are two main other properties of the metals that we have already discussed in our lower grades. That is, they are malleable. They exhibit the property of malleability. What is malleability? What is malleability? Malleability is the property of a metal to be beaten into thin sheets. We can beat the metals into thin sheets. Their property, we call it as the malleability. So metals are malleable. They exhibit the property of malleability. Okay, which are the most common, which is the most malleable metal? The most malleable metals are gold and silver. Gold and silver. So gold and silver are the most malleable metals. Most malleable metals are gold and silver. Okay. So what is the next property? So they are exhibiting the property of malleability. So they will exhibit the property of ductility also, right? Ductility. What is ductility? The property of the metal to be drawn into thin wires. Thin wires. We can draw the metals into thin wires. That property we call it as the ductility. So we can make the metals into thin wires. That property we call it as the ductility. So metals are ductile in nature, they are malleable in nature. That is why we can they can be beaten into thin sheets, they can be drawn into thin wires also. That is why we can make into different sheets. We can make the metals into different shapes according to our needs. We can make the metals in different shapes. We are having different shaped cooking vessels in our home, right? So we can make a different variety shapes of the cooking vessels. Why? Because metals are ductile in nature and they are malleable in nature also, right? Which is the most ductile metal? Which is the most ductile metal? Gold. Gold is the most ductile metal. So gold is the metal which can be drawn into very thin wires. It is said that even 1 gram of gold, even a 1 gram of gold, we can drawn into thin wires of at least 2 kilometer length. Right? Using 1 gram of gold, we can make a 2 kilometer length of thin wire out of it. Okay, so that is gold is the most ductile metal. So that is why we can make the metals into different shapes. Okay, then they are good conductors of heat. They are very good conductors of heat, right? And they are very good conductors of electricity also. They are very good conductors of electricity also. We are using copper wires, right? We are using copper wires for conducting electricity. You can look at in your home and you can see a lot of wires. You will get the wires, right? So normally these wires will be coated with some PVC or something, a rubber like material will be there, which is surrounded in the wire. Inside this coating you can see a copper wire in it. That wire will be actually that metal, that will be a particular metal. So metals are conducting in nature. That is why we are using metals, normally the copper and all. no, inside the wire you can see the copper metal, but this wire, this inside this copper metal, it will be coated with, it will be having a coating with the rubber like material or a PVC or something will be the a rubbery like material will be coated around this metal, because this metals will conduct electricity. So if we happen to touch it, what will happen? We will get electric shock. So what we will do is we will coat it, we will have a surrounded it with a rubber like material or a PVC type of materials will be there. So it's a very good conductors of heat and electricity. Okay, which is the best conductor of heat? Which are the best conductor of heat? Best conductor of heat are again silver and copper. Copper, silver and copper. Silver and copper are the best conductors of heat. Okay, then which are the very poor conductors of heat? This is the best one. Which are the poor one? Poor conductors of heat, which won't conduct that much of heat? Lead, Pb, then mercury, Hg, mercury. These metals are poor conductors of heat. They are lead and mercury. Which are the best conductors of heat? Silver and copper. Next property of the metals are they are having high melting point. High melting point. We need to apply lot of heat energy, then only it will get melted. So it is having a high melting point. It's having high melting point. The last property that we are studying over here means when we strike on the metal surface, you can see a particular sound will be produced over here, right? When we strike on the metal surface, we can hear a very good sound. What is that? Metals can produce sound. That property we call it as the sonorous. That property we call it as the sonorous. Okay, so sonorous, they exhibit the property of the sonorous. Okay, just go through the physical properties of the metals one more. They are exhibiting metallic leisure, they are hard, they are malleable, they are ductile, they are very good conductors of heat and electricity, then they have high melting point, and they are sonorous also. Okay, so just the opposite, just the opposite will be the properties of the non-metals. So non-metals will be exhibiting the properties just opposite of that of the metals. What are the common examples of the non-metals? Right? Non-metals are carbon, right? Sulfur, right? Iodine, then oxygen, hydrogen, etc. So these are the main examples of the non-metals. Carbon, sulfur, iodine, oxygen, hydrogen. These are the examples of the non-metals. Okay, these non-metals will be normally it will be in the solid state or in the gaseous state. Normally these non-metals will be in the solid state or in the solid state or in the gaseous state. Okay, so these non-metals will be in either in the solid form or in the gaseous form, but there is an exceptional cases, the bromine. Bromine is a non-metal and it is in the liquid state. It is in a liquid state. Okay, so what are the main properties of the non-metals? Just the opposite of the metals. It won't be producing, it is not exhibiting the metallic leisure, it is not hard, it is not malleable, it is not ductile, and it is not a good conductors of heat and electricity. It is not having a high melting point, and it won't exhibit the property of the sonorous also. So whatever that we have studied under the physical properties of the metals, that won't be shown by the non-metals. So physical properties of the non-metals will be just the opposite of that of the metals. So even though these are the main physical properties of the metals and non-metals, the general physical properties of the metals and non-metals, no, but there are certain exceptional cases in both the cases. Even though majority of the, most of the, or all the metals and non-metals are showing these much of physical properties, but there will be certain exceptional cases. So we are going to study about the exceptional properties of the metals and the non-metals. Okay. So we can just look at the exceptional cases of the general properties of metals and non-metals. So in the first case, we have studied that all metals are solids. We have studied that metals normally existing in the solid state. In a normal room temperature and all, it will be normally, in the solid state. But the exceptional case is the mercury, Hg. Mercury is not existing in the solid state. Hg is in the liquid state. Mercury, even though it is a metal, it won't be existing in the solid state, but it will exist as a liquid state. Right? Then we have studied that the metals are having high melting point and the boiling point. Here also there is a exceptional case is there are two metals which are having very low boiling point and the melting point. That means even if we keep that metals in our palm, that palm itself, in our hand itself, in the palm itself, it will get melted. So that much of temperature is required for those metals to get melted. So they are having very low melting point. So those elements are gallium and cesium. Gallium and cesium. So gallium and cesium are two metals. They are having very low melting point and the boiling point. That means even if we keep those metals in our palm itself, it will get melted. Okay. Then normally we have studied that non-metals are not lustrous. They don't have a very shiny appearance. But there is a non-metal iodine which is have a shiny appearance. It is lustrous itself. So normally non-metals are not lustrous, but there is an exceptional case, iodine. Iodine is a non-metal which is a lustrous itself. Okay. And again we have studied that normally all the metals are hard, but there are certain elements, so there are certain metals which are soft. They are lithium, then sodium and potassium. So these are the exceptional cases for the hardness. Normally all the metals are hard, but the metals like lithium, sodium and potassium are very soft. We can even cut them using a knife. They are very soft, so we can even cut with the knife itself. Okay, and they are having very low density also. They are having very low density and they are having very low melting point also. Okay, they are having very low density and they are having very low melting point also. Okay, again we know that metals are having high melting point and their density also will be very high, but these metals are exceptional cases. They are having very low density and very low melting point also. Okay, then the fifth exceptional cases, that normally we have studied about the non-metals, right? But there is a non-metal known as carbon. Carbon is a non-metal, and this carbon can exhibit in different forms. It can exist in different forms. Okay, one of the form, that property we call it as a allotrope. Allotrope, allotrope. That is property of the carbon to exist in different forms. We call it as the allotropes. So common allotropes of the carbon are diamond. Diamond is one form of carbon. Diamond is a one form of carbon, and carbon is a non-metal, right? So non-metals are supposed to be very soft, but diamond is the hardest substance, right? It is the hardest substance. Carbon is a non-metal, so non-metals are not hard, it is soft, but diamond, which is a form of carbon, is the hardest substance ever known, right? And they are having high melting point and boiling point also. They are having high melting point and the boiling point also. Okay, another allotrope of the carbon is the graphite. Another allotrope of the carbon is the graphite. Normally, nonmetals are not good conductors of electricity, but these graphite will conduct electricity. They will conduct electricity. Okay, so these are the main exceptional cases. The first one is all metals are solid, but exceptional case is the mercury. Mercury is a metal, but it is in liquid state. Then metals are having high melting point and boiling point. Again, the metals like gallium and cesium are having very low melting point, that they can even melt it when we keep it on our palm. Then non-metals are normally luxurious, not luxurious, but iodine is. Then metals are very hard. Exceptional cases lithium, sodium and potassium, which are very soft, that we can even cut it with the knife. They are having very low density and they are having very low melting point also. Then carbon, which is a non-metal, can exist in different forms. That property we call it as the allotrope. And two main allotropes of the carbon are diamond and graphite. And diamond is the hardest substance, but non-metals are supposed to be soft, but diamond is the hardest substance. Then graphite is another exceptional case. Graphite again, which is supposed to be a non-metal, is formed from a non-metal, so it won't conduct electricity, should not conduct electricity, but graphite is a very good conductor of electricity. Okay, so these are the main exceptional cases of the general properties of the metals and non-metals. So from here it is understood that just by knowing the physical properties, we cannot know, we won't be getting an idea about the metals and the non-metals. So in order to study more about the metals and non-metals, we should know about the chemical properties also. We should know about the chemical properties also. So one by one we can look at the what are the main chemical properties of the metals and the non-metals. Okay, so now we can look at the chemical properties of the metals. So one by one, all the chemical properties of the metals we can discuss. So the first chemical property that we are discussing today is the what will happen when a metal burn in air. Okay, what will be the chemical reaction that will take place when a metal is burnt in air. Okay, so what is this burnt in air indicates? Burn in air means the reaction of the metal with the oxygen. This we have already discussed, right? So metal burning in air means it's a reaction with the oxygen. So metal is reacting with the oxygen. Can you predict out what will be the product? When a metal is reacting with the oxygen, it will produce metal oxide. It will produce metal oxide. So this is a general formula. Metals plus oxygen gives metal oxide. Okay, so this is a general formula. When a metal reacts with the oxygen, it will form metal oxide. We can look at the examples. Example, right? We can break copper, right? Copper is a metal. So copper is reacting with oxygen, oxygen O2, right? Oxygen is a diatomic molecule, so we'll write it as O2. So Cu plus O2 gives copper oxide, will be metal oxide, means copper oxide, CuO, right? So copper oxide is in black in color, right? It will be black in color. This reaction we have already studied before, right? Just balance it. 2Cu plus O2 gives 2CuO, right? Then another example, aluminium. We can take the example of the aluminium, right? Aluminium is another metal. Aluminium plus oxygen gives metal oxide, means here it is aluminium oxide. What is the formula? Al2O3. Aluminium oxide will be formed over here. Just to balance it, 4Al plus 3O2 gives 2Al2O3. Okay, so metal oxide, aluminum plus oxygen gives aluminum oxide, right? So metals plus oxygen gives metal oxide. So copper plus oxygen gives copper oxide. Aluminum plus oxygen gives aluminum oxide. Okay, in the previous chapter we have studied that metal oxide. We have studied the nature of the metal oxide and the non-metal oxides. I hope you remember it, right? At that time we have studied that metal oxides are metal oxides are basic in nature. Metal oxides are basic in nature. How did we prove it? How did we prove that metal oxides are basic in nature? Right? These metals will react with acids to produce salt and water. We have studied the neutralization reaction. Acid plus base gives salt and water. Just like that, a metal can react with the acid to produce salt and water. So what does that indicate? Metals is acting like a base, right? It is acting like a base, so that is why it is producing salt and water. This we have studied in our last chapter. Right? So metals are basic in nature, but normally these metals will react with an acid to produce salt and water. These reactions we have discussed in the last class, right? But there are certain most of the metal oxides are basic in nature itself, but there are certain exceptional cases here. Exceptions are there means there are certain metals which can act as both acids as well as the bases. That means these metals can react with acids and bases also to produce salt and water. What does this means? This metal is reacting with an acid, so that is why we are saying that metals are basic in nature. So if the metal can react with the acids as well as the bases to produce salt and water, means metals are showing the character of both acids as well as the bases. So some exceptional cases are there. Some metals can have the nature of both acidic nature and the basic nature, and it will produce salt and water. So such type of metal oxides we call it as the normally the metals won't be reacting with acids. We have studied that metal oxides, right? So we can just write like the metal oxides. Metal oxides will react with the acid to produce salt and water, right? So metal oxides are basic in nature. So metal oxides are reacting with the acid to produce salt and water. We can write like that itself. So metal oxides. So there won't be any confusion. So metal oxides can react with both acids and the bases to produce salt and water. Such type of metal oxides we call it as the amphoteric oxides. Such metal oxides we call it as the amphoteric oxides. So what are amphoteric oxides? Amphoteric oxides are those metal oxides which is exhibiting the basic nature as well as the acidic nature. We call them as the amphoteric oxides. What does that mean? Such metal oxides can react with acids as well as the bases to produce salt and water. Okay, what are the main common examples we can take? Aluminium oxide. Aluminium oxide is such a case. Aluminium oxide is an amphoteric oxide, Al2O3. Then zinc oxide is another example, ZnO. These are the examples of the amphoteric oxides. So we can look at the aluminium oxide. Aluminium oxide, Al2O3 can react with an acid, HCl, to produce salt and water. What is the salt we are producing? AlCl3, aluminum chloride, and the water molecule also will be produced over here. the same aluminum oxide can react with the base also, NaOH. It will react with the base also to produce salt. Here which salt will be produced is a sodium aluminate will be produced. NaLO2 plus H2O. Right? In both the cases, aluminum oxide is reacting with the acid to produce salt and water. Aluminum oxide is reacting with the base to produce salt and water. Just to balance it is 6 HCl, then 2 AlCl3 and 3 H2O. Here also 2 NaOH should be the 2 NaAlO2. Okay, so aluminum oxide is reacting with the hydrochloric acid to produce aluminum chloride and water. Then aluminum oxide can react with the sodium hydroxide to produce sodium aluminate and the water. Okay, so such both the cases it is reacting with an acid, it is reacting with a base also to produce salt and water. Such metal oxides we call it as the amphoteric oxides. Okay, aluminum oxide is an example for the amphoteric oxides. Then normally metal oxides are insoluble in water. Yeah, mainly they are not soluble in water. But there are certain metal oxides which will dissolve in the water to produce alkalis. What are alkalis? What are alkalis? Water soluble bases are known as alkalis, right? Just for example, Na2O. Na2O. It is a sodium oxide. Can react with the water. It will dissolve in the water to produce NaOH. NaOH is an alkali. Right? Again, K2O, potassium oxide, can react with the water to produce potassium hydroxide. What does this indicate? This normally metal oxides are insoluble in water. It is insoluble in water, but the exceptional cases is that some of this can dissolve in the water to produce alkalis. Can produce alkalis. Okay, so just to go through whatever we have studied, chemical properties of the metals. What are the chemical properties of the metals? Metals will react with the oxygen to produce metal oxides. Examples: copper plus O2 gives copper oxide, aluminum plus oxygen gives aluminum oxide. Then we have studied that metal oxides are normally basic in nature because metal oxides can react with the acid to produce salt and water. But there are certain metals oxides which can react with both the acids and bases to produce salt and water. Such metal oxides we call it as the amphoteric oxides. So amphoteric oxides will have a basic nature as well as the acidic nature. Common examples are aluminum oxide and zinc oxide. Then we have got the examples of how does aluminum oxide is reacting with acid and how is it reacting with the bases to produce salt and water. Then we have discussed that majority of the metal oxides are insoluble in water. They won't dissolve in the water. Right? But there are certain metal oxides which can dissolve in the water to produce alkalis. We are on the examples also. Okay, so just write down all these chemical reactions and study properly. Okay, so we will continue in the next class.